and we're going to be talking about customized energy solutions, new approaches to an economical energy supply. And we're going to show you how to save energy costs, basically, or how to optimize energy costs by using local implementations. Well, I'm not going to do it, but our next expert is. So let's welcome him, Head of Distributed Energy Systems. Here's Dr. Bernd Koch. Welcome.
So yeah, hello to you all. I'm happy to see you here on Hanover Fair. My name is Bernd Koch, as you already heard, and I'm responsible for the Siemens business for distributed energy systems in Germany. So the next presentation that you are going to hear is about what exactly are we doing and why are we doing that. So mainly, one of the key indications we see is that the portion of the energy which is used in Germany coming out of the renewables is constantly increasing. The chart that you see here is showing that we have produced more than 30% of the energy that has been used in 2015 was actually produced coming out of renewable sources like wind and solar. These are the main contributors, and a little bit coming out of biomass. That's an important trend, and this trend is even more important because it's economically sensible, and it gets more and more sensible because the prices of the major contributors into the system, they are coming down considerably. If you look at that, for example, on the onshore wind turbines, looking at the last 20 years, the price is about half what it was 20 years ago. Even worse, this decrease in price is based on the PV solutions, the PV modules, as well as the inverters that you need to connect it to the grid. This price has come down by about 75% looking at the last 10 years, which is more or less the same for another key element, the storage element, the lithium-ion cells. They came down about in the same order of magnitude, about 75% during the last decade. And in the end, we have now a system where you have, on a cost basis, comparable or even lower cost compared to the traditional centralized system. And for that reason, we see clearly this is a shift, and this shift is going to be there as a constant change in the energy system. It's not like only because there is subsidies. No, it's really an economically sensible change in that. So we, from the Siemens perspective, we have identified mainly four segments where we really see these cutting into an economical benefit. First of all, there are optimizations based on grid fees, so how you connect to the grid, how you use your energy. Maybe some of you have heard the panel discussion earlier. We were talking about peak loads. So managing your peak load is giving you an economical benefit, and we can support solutions in this area. Secondly, about city districts and city district development, more and more the topic CO2 footprint is getting important. Sustainable energy supply, which is not only based on electricity, but also heat and cold for living and working in areas within cities or smaller towns is very important. Looking forward and seeing upcoming the challenge of e-mobility as well, connecting the infrastructure for charging poles is an important driver for that. Hybrid power plants, that's the next step in generating energy. So it's not only about gas and coal-fired plants. It's more smaller CHPs combined with PV, for example, or combined with wind to get these power plants in a constant production, and you really have them as a key player in the energy market. And last but not least, that's the key topic for this presentation. That's the energy park, customer-oriented. In this case, it's the industrial customer on site. You are now in a position to decide what's the best to do. Is it just buying from the grid and using energy as you did before? Or is it implementing in own generation and using that directly on site to optimize your overall cost for energy and potentially even make more out of that as soon as you have understood for what exactly you need the energy? Is it more heat? Is it more power? Is it a combination? Are there changes between days and nights? So how is actually this process optimized versus the energy production cost. I've prepared two examples to give you a little bit of insight what we are doing there. First is looking at how you optimize your fees that you have to pay in order to be connected to the grid. And of course, this obviously starts with the connection to the grid. So the first part you need is some sort of transformer where you connect to the grid. So that's the first step, obviously, because you don't want to run on an island. And the solution is still the German grid, at least, is pretty reliable. So you want to make use of that. Secondly, in order to manage your load curve, you need something which is able to react very quickly and to manage these peak loads. One of the key elements here is an electrical storage system, a battery based on lithium-ion cells. And what you see here is coming out of an example. You see how many times this actually cuts into on the basis of 1 year. It's about 530 events that you actually need the battery in order to control your load curve. If we have not only a small peak, but you need a little bit more energy over some period of time, it's not really cost effective to do all that out of a battery. So what you're going to use, you use what you typically know already, and that's a CHP. So you use the CHP in order to cover that for a longer time. And mainly the different what it is, you're now using the CHP electrically controlled, not thermally controlled. That's really the change. It's still the same equipment. It's just another way how to use it. And if one is not enough, you just add a second one. And what you see is that the number of events is coming down even more. And last but not least, in the very rare event that even this energy is not enough in order to cover your peak load, you get sort of a load reduction in your process. And based on this example, you see this at a maximum 4 times a year. Because this is what you normally don't want to do. You don't want to interact with your primary production process. That's only really in the case that you have a very strong deviation from your normal load curve. And 4 times a year, which saves you up to, it depends a little bit actually on the size of the energy bill you have, but typically this saves you about 15 to 20% of your energy bill. You have to take into account potentially 4 times 15 minutes change in the production might be worth it. And the good thing is that in this case, we did all the simulations, we did all the transients, that's all working. We did the right dimensioning, and we have a guarantee in place that you actually meet this reduction of your load curve. So this is where we see this is really you only can do that if you understand all the components, like the transformers, how they react, batteries, CHPs, as well as your process, how to control it and optimize it. A second example is looking at something that you can see over here as well, food and beverage. Typically you need heat, cold and electricity, so you probably have a CHP already. And this is why in this chart you see CHP optimization. In many cases we see that CHPs had been bought some years ago. They're still in operation, but first of all, you don't really know whether this is effective, or potentially you even know already that it's not optimized, but you don't know sort of how to improve it. And on the other hand, you potentially have CO2 targets. You want to reduce your CO2 footprint. So what we did in this case is we did a combination. We changed the way how the CHPs are running in order to have them on a more constant operation, not on a peak operation. We added PV generation. In this case, it was 3 megawatt peak, and a battery in order to optimize the use of the CO2-free production out of the PV cells, in combination with what we call microgrid manager. That's the managing software which is taking account about your use of the energy, as well as what the prediction of the weather is, because you need that at least in the 15 minutes looking ahead. How would be the sun actually helping this process? So you need a little bit of additional equipment in order to save money, and as you know, you need a little bit of equipment means you need a little bit of money in order to put that forward. And now there is the good thing from the Siemens point of view. It's not only about technology; it's also about financial offering. So what you see on the right-hand side is, first of all, there is a reduction in in energy cost, which is roughly about 25% in this case, which is a typical number. So we always speak about 20 to 30% as on average that you can save with such a solution. And on top of that, we have a financial model called managing service. That's a 10 or a 15 years contract where you have the equipment served all the time. And we take care about the capital invest, and you see sort of a managing fee for the next 10 to 15 years. And as this has a return on invest which is smaller than 10 years, in the end you see the profit or the benefit right in the first year. So which means in the first year after the installation you already get money back. That's a very good combination out of a technical solution that we really understand, and therefore we can guarantee the work and the proper functionality over the next 10 years. Combined with Siemens Financial Services, they take care about all the components, how to optimize that for your balance sheet. Looking a little bit in technology, this is mainly the examples that you have seen are examples coming out of this block diagram. This block diagram more or less is our blueprint, where you see all the components that we use in order to optimize that energy challenge. And in several workshops with you as a customer, we identify what are the core elements, how can we optimize them for your use, and finally to save money. That's the overall goal. We save money, and secondly, we save CO2 in using PV or wind generation on site. And I'm pretty happy actually in this position because I'm part of Siemens in this area, and we have combined the knowledge of many of our divisions because we really have a very good knowledge if we start from the power generation point of view, power and gas. So we know about CHPs, how they are working. We know about small industrial turbines, how they work and what the output is. We have a very good knowledge about energy management. So how are we sort of transforming the power from high voltage down to low voltage, how to distribute it. So that's one of our key knowledge points. We know how modern buildings are run in the building automation to optimize the buildings in this area, sometimes even to use buildings as a storage, as a thermal storage, for example. And last but not least, we know about production, like within digital factory and process process industries. We exactly know about how are the processes called, how are the processes run, and sort of in many cases there is an automation system of Siemens already there, and we can connect that into our overall solution, and we can combine it with wind power generation as well. So that's a very good position to be in from my side. So we have access to all this know-how, and from your side, because you have one partner you can talk to. Because we cover all this complexity, and from your end, we have a very detailed discussion on what's the benefit for you in this area. And one of the key drivers beside that are new technologies that we incorporate. And because these are incorporated into solutions, it's not that you have to bother about the nitty-gritty detail about the technology. This is what we are doing for you. In the end, we give you a performance, which is you get heat for the next 10 years, you get electricity for the next 10 years, and how we actually do that, this is what we cover from the technology point of view, and how this is financed, this is what the colleagues from Siemens Financial Services are able to cover and discuss with you. Some of these key innovations is we are back into the world of engines. So we have a gas engine with 2 megawatts that can run, of course, for generating electricity, but as well as CHP. We have Energy IP as the main cloud-based platform for energy combined or precisely running on MindSphere, which is the IoT platform that we use. So we are perfectly connected through that into your primary process. And it's a cloud-based solution as well, so there's no need for tons of computers at your site. Then we have cooperation with SMA for the PV topic. And last but not least, we see the storage topic. One is, as I mentioned already, electrical storage with a new product, Sealizer. And last but not least, we have an electrolysis, a solution which is called hydrolyzer. You can use that as the component into storage of hydrogen, but you can use it for several additional applications as well. And the next presentation is going to dig up in this detail a little bit to make that more transparent. Overall, to sum it up, this is what we understand in new approaches to economical energy supply with customized solutions. We use proven products, we combine it with a good business case and a financial solution, and we do that actually in workshops together with you to have the best solution for the next decade to come. Thank you.
Thank you also.